In this tutorial we'll learn about doubler panels and how to install them.
Alright, so I've done a lot of thinking, and remember, I'm an engineer, so I overthink stuff. But this area was gone and rusted from here down, just terrible. And so a lot of the metal, where I decided to say cut off and be my, this is good metal here and that's shit metal there, right? Well, after making those calls, when I started to do my welding of little repair patches into various areas, this is all new, Rimmer Brothers or Moss, I can't remember. But some of the welds were just blowing out because the material was not as solid as I thought it was. It was kind of half, whatever. So anyways, I've done all the repairs and welded them to where they need to be welded, and it's pretty good. So I'm sure I'm just kind of overthinking it and overreacting, but what I've decided to do is, in some of the critical areas, this one being critical, this one being critical because all the loads that are coming through the sill are being distributed through this panel, right? But they're also coming directly here. And the only thing that's here, really, is a couple of flanges that are overlapped, and then this piece of panel that came down. It has all these contours in it. So there was really only that one panel absorbing that load. And yes, you can think of loads as basically water, and imagine that the metal is like a paper towel or something, so you can see the flow of it absorbing the water. Okay, that's how you want to imagine the loading. So the loading came in here and was being distributed into all of this structure that is touching, right? Which is a lot, don't get me wrong. But right in this area is where I welded in a patch about this big and then said, okay, from here up is good material. Well, maybe it wasn't quite that good all the way, right? So I've put in a shear plate or a doubler, there's a couple of different names for it, where I'm just reinforcing this area with another piece of metal just to help move those loads and stiffen this area up better. I'm thinking I might do it here too, because again, this was all rusted away, and this is going to have a lot of rocks hitting it and things being thrown up at it. I might put a similar like doubler panel just maybe up here and over this lip right here. I'm thinking of doing that because I'm really impressed with this this panel bond. It's super duper like metal glue. It's awesome. So might do that again. Similarly, I did it at the back end too, because again, this is where you have the two inner wheel wells are welded along a seam here that comes down. And if you remember, all of this area was gone on mine. And similar to the front, this area is where all the loads of the sill are absorbed, are handled, attached. So again, I've put in a doubler / shear plate here, panel bonded in. I'll be machining off the heads of the screws, etc. Because again, this is where everything comes in and culminates. I want this to be very stiff, good metal, where the loads can get distributed throughout this area evenly. And I've done the same thing on the other side. So that's what these are. You won't notice them in the end. They'll all be sanded and nice, and this will all be 2K epoxied. And then I'm going to be putting the truck bed liner over this to give it that nice texture and It'll cover up a lot of imperfections in here. It'll look beautiful. Here's my blue tape mock-up of a panel. It's going to start here, come down and bend to double this, and wrap under here about 1 inch. And then I'll bond that in, and I'll have a good, secure, thickened area of the wheel well where it'll take all kinds of debris hits here. Again, that's that shear panel I put in. So I will feel very happy knowing that this whole area, which was compromised due to rust and corrosion, is now really solid, really reinforced. Nothing to lose. It's in a wheel well. It's not a cosmetic area. And by the time you've got coatings and other things on it, you probably won't even see it. All right, I bonded this panel in for added stiffness or added load distribution through this fender and sill assembly. And though I trust the panel bond, nothing beats a good mechanical fastener, because if anything wants to give in here, it'll be a shearing motion. And by adding a fastener in, it's got to shear through all the fasteners themselves. So I'm using stainless steel, because if you use aluminum, it will react with the steel. All right, so here's one of those doublers or shear panels or whatever you want to call it. But I'm going to put it in this area here because, again, I just want to beef up this area here. I'm going to make another one here also, but because I thought this one would be good enough, and it probably will be, but you know, better safe than sorry, because again, this is where everything gets kicked up and hits right here in the back of the fender here, back of the fender well. So I guess I'll show you the panel bonding experience, but it's just like putting on glue or caulk or anything. And then I use self-tapping sheet metal screws to hold it in place till it dries. And then, like you saw on the previous ones, I'll rivet those into place, and this will be stronger than it ever has been. So tools needed, one of these. I'm using the 3M. I think there's one or two other brands, but you know, these guys probably invented this stuff, so it's proprietary. Just FYI, you can really trust this stuff. It's a modified version of what they literally glue airplanes together with, so I'm fairly trusting of it. Airplanes are all aluminum, so it's a slightly different mixture, but they've pretty much got the tech down. So I need to just do some more prep. I've scoured this with, I think, 80 grit, maybe 36. You just want it to get a bite. Whenever they talk about adhesives getting a bite, they're talking about little scratches and ridges in the material, the plates you're trying to bond, so that the adhesive can go into those cracks and make a mechanical adhesion. So that's why you scuff up all the areas you're going to be gluing. So I need to still scuff this area. Let's do that. In this case, I'm using 36 grit. So a couple of things just to point out is I'm going very slow with the spinning, because I want to cut deep grooves. I don't want to, even at 36 grit, you can kind of polish it if it's, you know, hauling ass at super high RPM. But real slow, you're literally just digging gouges into the metal. And plus I don't want to remove metal, so again, I just want to etch it. How high do I have to go? Alright, that should be good. The other set of instructions is that it's got to be metal to metal bonding, so that's what I got here. I'm just going to get some acetone real quick and wipe this off. All right, we're ready to go. So it says to put a bead on your project. Notice it's a mixing tube. It swirls it as it goes down. They say don't use the first tip of it, although they just want you to waste it. I don't believe that, but all right. Anyways, here we go. So I'm gonna go around the periphery. Some of this shit here. I'll put some on here. I've got about with this particular mixture, I get about 90 minutes of playtime, so you don't have to rush. Alright, so there's that first coating, and then they say to do this kind of distribution of it. So that's that, and I'll do the same thing here. Just so this just kind of maintains so that any contact anywhere will glue, because this is slightly deformed and bent and warped, as is the piece in my hand. So that's what this coat does. I guess I'll just point out also, this stuff has, sometimes it's called micro balloons or whatever, but it's small small beads in it that are there purposely. Now I'm going to go around the periphery per instructions, because you want to witness squeeze out, so that you know at least it's bonded around the edges. All right, so that's that. Not too messy. Where's my screwdriver? All right, so self-tapping screws, and then just go to town. Since it's pretty thick, it'll kind of stay in place now. That's what we're looking at there. So let's maybe blast one in here. Okay. Let's go in here. Put that in. Could have drilled holes and put clecos in, but decided to go this route. These have more PSI of pull power than a cleco does, so you're better off with this when you need tighter clamping. Thank you. All right, so that's not going anywhere, ever. There is a plate that comes down here, kind of holds the fender in position, but it's got a seal around it. So like here's one hole, two holes. I'll have to find that one and drill it through. There's another one here, so no big deal. It'll all be done. So yeah, I'll just smooth this out where the squeeze out occurred. Aesthetic reasons only. You can sand this stuff after the fact. It's just like putting Bondo on or a sealer. I think we're good. We're good now, good now, good now. I'm gonna put one right here because I got a little bit too much gap right there. Let's pull that one in just a little bit. Alright. With that, we are good to go. This takes 24 hours to dry. I gotta pick up another piece of sheet metal. So to date, I've probably put in 2 panels, 2 replacement pieces of sheet metal that were about 2 feet by 3 feet. So I've got 12 square feet of metal that I've replaced here and there. The footwells took a majority of that because it was a big piece like this. And then these are fairly big. The rest is just little knit parts here and there. But I need one more piece to make this piece and the similar one on the other side. All right, so I went from the paper template to the actual part. There's the template on top of it, so to speak. And then after some coercing, it's gonna fit in there just fine. And I sheet metal that in with the panel bond. That's gonna be really rigid and good. The other side's a lot easier. It's just one bend. So I don't know if I'll film that or not. So ready to go with that. So while I have some panel bond left over, let's take care of these 2 doubler plates that go here and then on the other side. Same old stuff. Gonna put the glue on, spread it around, sheet metal it in place. I'll show you it when I'm done. So here's the passenger side footwell with all the doublers and some bad primer paint on them, but you can say I replaced the sheet metal screws with rivets now. Here is the passenger's rear fender well with the doubler panel in place, panel bonded and then riveted. This is the driver's side rear fender doubler panel.
completed and primed. And finally, this is the driver's side footwell with the doubler panels in place and temporarily primed over.
Thanks for watching. Hope this information was helpful.